density is a physical property. Is it intensive or extensive? Density?
Extensive.
Intensive.
Wait, so density is a physical property?
Yes, ma'am. It is an intensive physical property.
Yeah.
A lot of you, if you don't know what a word means, you're like, oh, it sounds good. So density is actually, remember we changed the pennies into gold, right? And then I told you about King Arthur, how he thought his crown had gotten stolen. And he told Archimedes, hey, you need to figure out if my crown is real, because I don't think it's real. And he was an alchemist, where he would change things into gold at the time. So he's like, you know what, I'll see what I can do. So one day Archimedes is going to take a bath. He fills it up with water, and he sits in the bath, and he sees the level rise. And he's like, okay, now I know how I can figure out the volume of it. I can weigh it, but I couldn't figure out how to get the volume of the crown. So he used something called water displacement, which is what you guys are going to do on Friday. So he was able to get the volume, he was able to get to the mass, and density is mass divided by volume. From your knowledge, mass and volume, are they intensive or extensive? Extensive. Mass and volume measure. They measure matter. Density is mass and volume together. So density is actually exact. Gold has an exact density value. Doesn't matter if you have a small bar of gold, a necklace of gold, the density will always be the same. That's why it's intensive. It's independent of the amount of matter present. But these two alone are extensive. When you put them together, you get intensive. So what happened was Archimedes, he went ahead, he figured out the density of gold, and he got a gold bar, figured out what the density was, and then he got the crown, figured out what the density was, and they were different. So in fact, King Arthur's crown was actually stolen. And at the time, people were trying to change things into gold. So they called them alchemists, which I wish I was part of the group alchemy, just for that name, because it's chemistry. So alchemist means trying to change something into gold, but when this happened to King Arthur, it was illegal. It was illegal to even try to, because he was worried more people were going to steal things from him. Okay, so density equals mass over volume. Now, we have three different types. We can have a solid, we can have a liquid, and we can have density of gases. The difference are their units. Okay, and you guys have learned about units. We talked about grams and milliliters and liters and kiloliters and kilograms. So the units for a solid are grams per, guys, this means per, okay? I've seen kids actually write PER. You don't have to. The slash means per. So grams per centimeters cubed. That's how you know it's a solid. Grams per milliliters. Milliliters, okay, it's a liquid. And gases are grams per liter.
That could be like gallon.
For
Like, you know how cars, they put gallons.
for liquids, actually gallon is a volume. It is volume. But in chemistry, we use the metric system, so we use liters, milliliters. But yes, that is a form of volume. Now, centimeters cubed, how many of you have seen that before? Centimeters cubed. Probably in algebra, right? Algebra 2? Well, if you were given centimeters cubed and you need to change it to milliliters, there's an easy conversion. 1 centimeter cubed equals 1 milliliter. That is so good to know. A centimeter cubed is equal to a milliliter. So technically the same. Whatever you get here is going to be the same there. Okay, so let's take a look at density. We have block A on the left. We have block B on the right. Which one? And they both have the same, these are called atoms. They have the same substances or same atoms in them. Which one do you think has a greater mass? Very good. Why A? Has more of these red spheres, right? And they're, Okay, so then which block has a greater volume? So you want to see these spheres and which block takes up more space? A or B?
B.
Everybody tells me B because they see a lot of empty space, but this means that there aren't that many, so it's a small volume. Okay, so you need to think the opposite. You see how there's more spheres? That means that A has a greater volume. Next question, which one has a greater density? Are these spheres both red? They're both round. So we're assuming it's the same substance. So even though that B has a greater mass, it has a greater volume than, even though A has a greater mass and volume than B, doesn't matter, it's the same substance. So then their density is the same. So going back to King Arthur, had his crown been gold, the density would have been the same that Archimedes found for the gold bar. Okay, it doesn't matter how much you have, the density is the same. That's why it's intensive. Next one. If the block was cut in half, so we have this block, we're going to cut it in half. What would be the relative density on each half? What do you think? Isn't it the same substance? Still red spheres, right? Then the density, even if you cut it in half, the density is the same. Okay. It doesn't matter how much you have of something, the density will be the same. Water's density is 1 gram per milliliter. Doesn't matter if you have a cylinder of water or a gallon of water, it's going to be the same. Next question. What has a greater density? So we want to know what has a greater density. When I do math problems, I've always circled a question and then I underline what they give me. So what has a greater density? A gallon of feathers or a gallon of gold? Okay, so what's the formula for density, guys? Mass over volume. The variables are M over V. Okay, so we're going to say feathers. Feathers, which one's going to be heavier, feathers or gold? Okay, so let's just say that the gold weighs 12 grams. That's 12. Right? And it's, of course, it's over 1 gallon. What's 12 over 1? 12, right? 12 grams per gallon. Feathers. Let's say the feathers are half the mass. Well, half the mass of that is 6. 6 over 1 gives us 6 grams per gallon. Right? So which one's going to have a greater density? The gold or the feathers? The gold. So. Oh. This is why I don't record for spirit, because I'm usually still asleep. The gallon of gold. Next one. Which one has a greater volume? So what has a greater volume? A gallon of feathers or a gallon of gold? Feathers? Someone says feathers. Anybody else? Feathers? Anybody beg to differ? Melissa, what do you think? You always have wise things to say. Cassandra, what do you think? No? Nicole? Which one has a greater volume? Feathers? Anybody different? Gabriel? What do you think, sir? Gold? How about they're the same? Why do you guys think they're the same? There's a key word here that you're missing. 1 gallon. Nice. They're both 1 gallon. Trick question. They're both 1 gallon. So their volume is the same. It's when we look at mass that it's different. So next we have, what has a greater mass? A gallon of feathers or a gallon of gold? Now, which one's heavier? Gold. Trick question in that second one. Now, this is the theoretical part. A lot of kids hate the theoretical part. The part that I'm interested in is, can you work it out mathematically? So, right below you should have these problems. Yes? I'm going to go ahead and move it down a little bit just so I can draw a picture. Okay, so a rectangular piece of cement has 2 centimeters by 2 centimeters by 3 centimeters. Calculate the density in grams per centimeters cubed if the mass is 0.108 kilograms. When I do my math, it has to be like written out completely and it has to look nice. I don't know, it's just the way I am. So I like to write everything out. So it's saying calculate the density. So we don't know what density is. Big question mark. And the mass is 0.108 kg. And they gave us volume. But what I'm going to do is I'm going to come up here and I'm going to draw a rectangle. We have this rectangle and it says that its dimensions are 2 centimeters by 3 centimeters by 2. This is the volume. Well, what's the volume of a rectangle? So think algebra. Nice. Volume of a rectangle is length times width times height. So I'm going to go ahead and multiply everything. 2.00 centimeters times 3 centimeters times 2 centimeters equals. So 2 times 3? 6 times 2? 12. So our volume is 12.00. And then how many centimeters are there? 1, 2, 3 centimeters cubed. Everybody needs a calculator. So go ahead and get one. And I'm going to pause it. Continue. So if we take a look, we don't have density, we know what mass is, and volume. We just found out our volume. The other problem is, what are the units for mass? Kilograms. What do we need? No. We need grams. Because it's grams per centimeters cubed. Okay, so I'm gonna do something that I said I wouldn't, but it's going against everything that I believe in. But it's for your benefit. I don't want you guys suffering. So will you do me a favor and flip to, I think it's page 9 where you have prefixes? Yeah. Okay. So just put your pen or put something on this page and just flip to page 9 real quick. I'm gonna show you something. And I want you to write this in there. So we have kilo, hecto, deca. This is a meter, a liter, a gram. These are called base units. Right? What comes after base unit? Okay, and that's it. To nano, I'm good. Okay. Now remember, there was a pattern. These guys were 10 to the 0, and this is 10 to the first, second, third, and this is 10 to the -1, 10 to the -2, 10 to the -3. What happens from milli to micro? -6, and then micro to nano? 9, right? So what's the difference here? 3. What's the difference here? 3. Okay, remember that. If you were going from kilo to nano, you need to move the decimal right. many times it takes you to get there, you need to move the decimal right. Okay, so let me give you an example. I'm just gonna write it over here so you can see. How many kilograms do we have in mass? What's on our problem? 0.108? We have 0.108 kilograms, and we want to convert that to grams. So 0.108, we are going to go from a kilo to a gram. How many times are we going to move downstairs? 1, 2, 3, right? We're going downstairs, so we got to move the decimal right 3 times. 1, 2, 3. So 108 grams. Done. Do you guys see what we did? Is that a little bit easier or no? Now, what if I wanted to go from 0.108 kilograms to centigrams? Okay, so I start with my number. Centi is 1, 2, 3, 4, 5. It's 5 places all the way down. So I'm going to move this to the right because I'm moving downstairs 5 times. 1, 2, 3, 4, 5. Fill in the zeros. 10,800 centigrams. No fractions, no nothing. It's just moving decimals. That's all you're doing. And it's funny because, like, even when I used to teach this, even my AP kids, they hated the fractions. They would rather do this. They would even like move it in their head. At this point, guys, whatever way works for you, if the fraction works for you, just shut me off right now. Don't even pay attention to this. Because that's probably the proper way of doing it. But to me, some of you just hate fractions, so this would be better for you. All right, well, what happens if we're going upstairs? We're going to move the decimal in what direction? What do you think? We're going to move it left. So if we go upstairs, move decimal left. So some examples, if I have 10 micrograms and I want to know how many hectograms. Well, here's micro. What happens from micro to nano? From micro to milli?
3.
3. So I'm going to go 3, 4, 5, 6, 7, 8. So this is going to move 8 times to the left. It's really small. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. Fill in all the zeros. And there's your answer. 0.12345 610. Okay. Whatever helps you, I don't care. But in density, we use metric conversions. So on your test, when we have a test, you're going to need to use metric conversions. And again, I'll let you use the chart. You just need to know how to work it. Okay. I went from micro to hecto, and I had to go up 8 times because from micro to milli, there's a difference of 3, right? So I go 3, 4, 5, 6, 7, 8. Since I'm going upstairs, I need to move the decimal left 8 times. And in 10, we don't write 10 dot, but technically the decimal is after the number, and then you move it to the left 8 times. Okay? All right, so just in case, little refresher. All right, so we are here. We just figured out that this was 108 grams. So if you want to go ahead and flip back to page 18. Okay, Noah, what's the formula for density, sir? What does M stand for? Daniel, look at this. You want to help them out? Thank you. And what is V, sir? Nice. So we plug in we have 108 grams divided by 12.00 centimeters cubed. Go ahead and plug it into your calculators, guys. 108 divided by 12.00. Tell me what you get. Nice. 9.00 grams per centimeters cubed. I am not going to be big on significant figures with you all. Just give me 3. I noticed like in algebra classes, a lot of you will plug in like 9.00, 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't plug in everything. Just give me 3 numbers. I'll be happy with 3. God bless. So we have our answer. Next question. Gold has a density, so they're giving us the density of 19.3 grams per centimeters cubed. What is the mass in pounds of 7.25 centimeters cubed of gold? So not only did they give us density, they gave us volume. And they told us it was 7.25 centimeters cubed. What is the mass? Okay, so we set up our formula. So they gave us the volume. They gave us the volume this time, and they gave us density, but not mass. Okay, so Abigail, what's the formula for density? Mass over volume. I always write formula because it just helps me set it up. We know that this is 19.3 grams per centimeters cubed equals, we don't know what that is, but we do know that the volume is 7.25 centimeters cubed. So, hint of advice, anytime we are looking for mass, you multiply these two. So, mass is going to equal density times volume. And it's just a matter of isolating the variable, which you guys are learning in algebra. So we want to get rid of this one, just multiply it over here, and you'll get mass. So 19.3 times 7.25, go ahead and plug it in. 135? 139.9? 25 grams. Well, this was grams per centimeters cubed. This was centimeters cubed. These cancel, and you're left with grams. And we were looking for mass. Mass is always in grams. Yes, it is. It was 2.5 though, wasn't it? So I rounded it. Any questions? Danielle, do you have a question? No? Next one. Next one. The density of sulfuric acid is 1.84 grams per milliliter. So density, 1.84 grams per milliliter. The mass of the sample is 25.0 grams. What is the volume? And then they want it in liters. How dare them? Oh, we weren't even done up here. We're done. I'm going to leave it because we're not doing English conversions in here. We never go from grams to pounds, so don't worry about it. But this one you do have to worry about because it's metric. Okay, so Melissa, what's the formula for density? Nice. They gave us density. We have mass. We don't have volume. So check this out. All you're going to do is you are going to flip them. So you will flip the variables. So volume is going to equal 25.0 grams over 1.84 grams per milliliter. and you divide them. So you don't have to, I mean, we isolate it. It literally works out if you just flip it. And what do we get? 19.5? 5, 8, 7. I remember I told you guys just 3 numbers? So 1, 2, 3, look next door. Is that 5 or more? So we'll say 13.6 milliliters. But are we done? What's the question asking for? It's asking for liters. By the way, I just deleted this. So we are going from milliliters to liters. We're going upstairs. So we're going to move the decimal right or left?
Left.
Left. How many times does it take to go from milli to liters? 3. Because milli's 10 to the 3, so it takes 3 times. So this is going to be 13.6. 1, 2, 3. Fill it in. So it's going to be 0.0136 liters. There's our final answer. Okay, so on your paper somewhere, let's write the formulas. It's density equals mass over volume. When we need to figure out mass, what did I tell you to do with the variables? Multiply them. Density times volume. If we need to find volume, what do you do now? Yesenia? Okay, forgive me, it's not you. Because I'm always yelling at Daniel. Oh, me? Yasmin? Yes, okay. What do we do now, Yasmin? We divide them. Sorry, don't take it personal. Okay. Remember this. You guys have homework. I don't give that much homework. Okay? I don't think I do because I'm So you have homework today. Tomorrow, I want you to do a lab. We have a lab tomorrow. So if you don't do the homework, you're going to be kind of lost as to what you're doing in the lab. So please do your homework. We have a lab tomorrow, and then Friday, if you have any questions, we can go over the density stuff. Okay? Thank you.